Hello everyone, I am Bradley Sward, Associate Professor of Computer Information Systems at the College of DuPage in Glen Ellen, Illinois. And this video is part 12 in a series of videos where we're going to take the game Boxxle / Sokoban, and we've already converted it into GameMaker Studio 2, works great. We are in the process now of moving it over into the C++ SFML engine. So this video, what are we doing again? The whole main goal is to create a Boxxle Sokoban game where you're pushing blocks around from here to goal, 720p resolution, 60 by 60 tiles. We're getting closer and closer and closer to finishing this thing off. We're who knows how many videos away, but we're getting closer for sure. So what are we going to be doing this video? So we're going to clean up the gameplay room a little bit. I'm just going to pass a couple parameters into this thing, so we only need one room to handle any gameplay room that we throw at it. We'll see that in a minute here. And then we're going to add functionality. I'll show you in a second here. GameMaker has a ton of variables under the hood if you don't already know, and we're only going to do these today in this video. Some of them are easy, some of them are going to be a little more challenging. So then we say so we're adding movement and general variable functionality to this object class. And again, we're only covering the basics. There are, basically if we wanted to and we have the time and the means and everything, we could go ahead and basically recreate the entire engine if we wanted to. But that is not the goal of this course. The course is just to get you an introduction to this kind of thing. So that is what we're doing. And again, so in the help, here is everything under instance variables. I usually just go and look up X and then I work my way backwards to find this, because you can see there's all of these different variables that every object can have. And so this video is going to handle just a couple of these. Next video, or video very soon, is going to cover all of the sprites, because we still need to add animations and we still need to have that kind of stuff when it comes to having the player move around and walk around and do sort of with animation frames and things like that. And then we're also going to have to deal with bounding boxes, because they're going to have collisions and they can move around. This is what we're going to cover today, and all this other stuff. Just more complicated. So pathing routines, timeline routines, adding a physics engine on top of everything else. I think it's, what is it, 2D Box 2D or something like that is used under the hood. And so again, the help is your friend, right? Especially this is everything you can do in GameMaker, and we're only going to cover that little tiny bit of it. Okay, so just getting back, that first item of business was for us to clean up the Boxxle game level. So to do that, notice how I've hard-coded this guy in here. And I'm like, well, I don't want to do that. I would love to be able to say, let me pass in const std string reference to the file name. And then also pass in level number. Because maybe you can imagine when we play this, I only know what file is open, but I don't know if that's level 1, level 2, level 3. So I have the ability to pass this number along and pass something along so that this thing is maintained under the hood. So I can have a private. I don't necessarily have to save the text file, but I should probably save the level number. So I'll do something like this, have this set up. And so cool, fair enough. So then what I can do here is steal this guy. So I can copy paste this in. Let me bring this down a notch. Make it a little more whatchamahooey here. Okay, so all right, so then int level SFML room. So this file name becomes this guy here. And I'm not passing up anything to the base class, but afterwards I still have to set up my level number and and we're not going to use this here. This is for later videos. And so there we go. And just to have something here, what should I do? Oop, I don't even have cout available to me. I will just throw. Do I have exception? Okay, I have exception at least. Text file not available for loading, or something like that. Just so I have something that will crash it in a way that's acceptable to me rather than something that's not acceptable to me. So throw an exception if the file fails. Okay, so that should take care of the object layer stuff, and then there's going to be an error that pops up. I like using the compiler to find my errors sometimes. Come on, there it is. And this is just a matter now of making sure I put in, I need to pass in level 001 room.txt and a 1 inside of here, and if I did everything right, it shouldn't take long to figure out, and there we go. We don't notice any difference, but there the game is refactored, and my level is still running perfectly as I want it to, and now it'll be real easy, because in our main menu when we do this, we'll just pass along this. We don't have to have a level 1 room, a level 2 room, a level 3 room, a level 4 room. We don't have to have 600 different objects. We just have one object. We pass along the text file, because the whole game plays the same. It's just a matter of having the player push the blocks into the goals, and then when you find out that you won, use that level number to check out to see, did I beat the best score? And so then all of that can, it's pretty slick and smooth, because it's all already handled in here. The level number is stored when I get to that point, and with all the objects and everything else, and it'll be pretty cool. Okay, so that covers that aspect. Done. And I can get rid of this for now since we don't need it. Okay, so now coming back, we're going to start playing with the object class. And so what are we going to try to do? So we already saw here that we can set the position of the X or Y position of an object using the set position function. And so, but we're trying to mimic GameMaker Studio as best as we can. So I'm going to start creating some functions that mimic and just, and I would love to say we could use C# here and use what we call properties. So I don't have to have like a get or set function. I could use the variables, and the functions are functions are generated as if you're using a variable, and it just like GameMaker x = 9. That would be great, but we're going to have to be like set x 9. We're going to have to write a function for this, which is unfortunate. The language does not allow us that simplicity under the hood. So, but some of this stuff is really simple. So I'm going to start with the x and the y, because we already know how to kind of do that. But so this thing's just going to start jamming up with functions here. So I'm going to say this is, we'll use a double. No, actually, what is sitting under the hood? Set position, float. Okay, so we'll float x, x, and void set x. So just so you don't have to type out get for the variables that are the functions that are gets, I'm just going to call them whatever their name is, and then the sets will very specifically be set. So I'll just say, okay, here we go. So for this, and so for x and y, and say, so this should be fairly simple. I just have to implement these now. Where did they all? The whole question is, where did they go? Here we go. So return. So now here's the fun part, right? Like, what am I returning? I'm returning sprite get position function dot x. So that value is already stored under the hood. There's no reason for me to maintain a second copy, because that just adds confusion and the possibility of bugs. So this is the same thing of what I would do for the y function. Just get me the y position. And as you can imagine, then I can go ahead. This is the tricky part with this. Let's see if I can set the position. I don't need a return here. I can say let's set position. Let's see what functions we have. Set position, and we have 1 and 2. We have, all we can do is do an x and a y, or we can set the entire thing. So shoot, what? So we're changing the x, but we're trying to leave the y alone. And what's unfortunate is we kind of have to resolve to this since we're not storing the variables under the hood. So we're saying, okay, I have to basically beg you, tell me what the y position is, and then fill that in. And then I'm going to modify the x, and then so it's just the reverse then for the y. So basically, have the sprite get the position of the x, because I don't want to modify that, but then now I do want to modify the y as that comes in. So okay, so that pretty much covers. So one way I can test this is we have our player here. Let's see. Let's run our game one more time. Let's just make sure everything compiles. It's taking longer and longer already. Oh, I have some warnings I got to take care of somewhere along the line. So here is our thing. So what I could do just to test this out, say, hey hero, oops, not hero.h. We'll just say hero.cpp. Where are you? Here you are. And we'll say, oh, okay, I will need the hero.h. and say, let us create virtual void step override. Let's take over the step event. And let's start doing something. So I can say here, set x plus 1. And let's see this in action. Let's make sure it's working. And oops, won't let me drag. There we go. So every game frame, he's moving over 1 pixel. There you go, right? So we've depth ordering, right? So that's a later issue. So we have it. If you want to try the same thing, just to make sure, let's make sure he's going diagonally. And he is. And oops, why doesn't it? There we go. So he's moving. The x's and the y's are being set and get and all of that. So I'm fairly confident that we already have the good work going here. I don't have to worry about the .h anymore, but it would just be the .cpp to test this thing out. So I have my functionality now for my x's and my y's. Okay, so moving on. Next thing I want to do is set up a start position, x and y position, and that I do have to maintain myself under the hood. And so sf vector 2f, not a pointer or anything. Don't have to worry about any of that kind of stuff. But I'll be calling this start position. So position is already taken care of for us. So start position under the hood is just a vector 2f. And so what I can do here is I can say start position is how am I initializing this xy. Whatever position you tell me, that's the start position. And I'm allowed to use a 2-parameter, right? I'm allowed to use the 2-parameter xy to get this thing going. Here, let me, while I'm thinking about it and I'm building all this stuff, what are my warnings? Oh boy, I have quite a few warnings. Ay, what is going on here? Let's see. From int to t, wait a minute. Oh, okay, this is, this just goes back. This is, oh man, I did this all wrong. We gotta change all the ints to floats. Oh man. So this is gonna propagate all the way down through everything. My bad, everybody. Ints, floats, what's the difference, right? We're using floats because floats are faster than double, and when it comes down to it, you're not gonna notice if you're off by a 1/4 pixel. You're really not. So let's see, what is this break? I should have just a ton, yeah, like a ton of warnings right now because I just changed, and everything is like, what about this int to float stuff? I'm like, oh boy. So everything needs to kind of get shot over. All the .h files that were using ints last time, I felt so smart about it. They're now using floats. Because the x and y can be fluid. It doesn't have to be tied to a very specific pixel on the screen. It can be tied between pixels, just like real life, right? I'd like to think we're not living in a matrix. Like to think so anyway. So let's just keep going. There's my box has got that. Here's my floaty. Here's my goal. Here's my hero. But this is, I only caught this because I looked at my warnings once in a while. I go, I treat warnings as errors. They're trying to tell me something's going to go wrong if you keep using the code in the way that you're using it. Oh goodness, what else is going on? Well, I've narrowed it down a little bit. So this should take care of the rest of it, I believe, if I just turn these into floats here in Boxxle game room level. Oops. Oh boy, hold on, that ran it. Let me rebuild it. And boom, 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 0, 0, 0, 0, 0. Hey, look at that. All the warnings, no errors, no warnings, and now we're all happy. I took care of that. I've got my floats now. Okay, so coming back now. So my X start, my Y start, get rid of you. Where are you? Object dot, where is object dot CPP? Let's get it back. Okay, so I have my start position, and it's the same as XY. Now it works just fine with the floats go in, the floats go over. And so now I just need get and set, because you can change the start position because it's just a matter, basically it's just like a holder for like, where would you want to go? So this would be, do we want to put the X first or the X after? I'm going to stick with the way GameMaker does it, and I'll say X start, and I'll say X start, and I'll say Y start, and I'll say set Y start. And basically we're just duplicating. They say we're going to do this one more time with the previous as well, and we do need previous for collision check. So it's not like, you know, I'm only doing the ones that matter to us. I'm not just doing these just to kind of spin our wheels. Okay, so then X start, let me just throw the word start in front of this thing, all of them, all of them, all of them, all of them. So instead of this kind of, you know, instead of setting the position here, I am going to say start position equals SF vector 2F instead. And so, oops, and then say start position dot. This will be easier when we do the third one because we'll have it all, the template already made up. Because right now we're hacking it over. So the start position, get me the X position, don't change the Y, or maybe I can, let's see, can I just do this? Sometimes you can, sometimes you can't. Let's see. Can I just say start position dot Y equals Y? Okay, now, okay, good. That simplifies things quite a bit. If I can do that, because sometimes, depending on how you do things, like you have a copy or something, it's like the compiler won't let you. So in this case, fine. I don't mind it. Whoops. Set position. Okay, I'm already losing myself in here. Okay, so let's just, okay, let's just kind of do this here. Okay, so my X start, this is setting the X start. No, it's not. This is getting it. Return. This is confusing. I'm just having a moment here. Start position dot X. Start position. Oops, let me see. Oh man. Okay. Start position. It's been a day already. Start position dot X equals X. Okay. And then for this one, return start position dot Y. And what was I even doing? Did I just do it? Oh man, I set the wrong place. Oh well. Okay, return set. I'll fix this up. I see where I see my mistake. It's real easy to get lost in these things. Okay, so X start position dot X. Set X start position dot X equals X. Y start, return the Y. Y set, take the Y in and set the Y. Yeah, so this is where I screwed up here. This is why I set X. Let me put this back. Sorry about that. And then I would say here, I'm going to say dot X comma Y like I did before. Okay, so cool. So I have my X start, set X start. So that should work. Let me recompile this one more time. Okay, so one thing we can try here just to test this out is to go back to our hero. Oh man, let me get rid of all this extra stuff. Simplify this quite a bit. Let's go back to hero.cpp. So we've got this stuff going on, and now we never use the keyboard class, but we can now. And what I can do here is say if SFML keyboard : is key pressed. So every time I press the key, so let me move this up here and say, okay, if key pressed, and so now which key, right? SFML keyboard : spacebar. Oh, : key, : oh wait. How do we get there again? It's been a while, right? Let's see. Oops, do I have? Oh, it's not SFML keyboard. It's SF keyboard : if I press the spacebar, and this is, again, this is the moment you press it down. Is it going to correct itself here? A non-static member variable. Oh, I got to do the get instance. It is. Oh my god. Too much thinking, too much talking, too much doing. I have to get the instance before I can do this, and if the space is pressed down, what I can say is set my x to whatever my get x start. I'm sorry, just x start. And I can put it right back to where it was. Okay, so here's that, and I press spacebar, and here we click it, and he goes right back to where he started from. So the X and Y position is set back. So we're happy. I finally did it right. Hopefully didn't break too much other stuff in the process. But now you can see, if I press the spacebar, yep, move me back to start. But you could also see then, if that's the case, not worrying about this stuff, instead of spacebar, let's see, how about right arrow? Right. How about this, right? Just see where we're going with this. X plus 60. If I press the the left, how about I go back 60? And so you can see I can go right and left. And that's all there is to it, right? We're getting, and of course we need if statements that are, we need some checks to handle collisions. But you can see I can't go up or down, of course, but I can go left and right, 60 pixels at a time. So we're getting closer to finishing this project up. Okay, so I'm happy with X start and Y start. Excuse me. So then the final one when it comes to this is just repeating this a third time, and I'll make sure I fully separate these so I don't confuse myself like I just did. And I'll do this for X previous instead of X start. And again, we will need this for collision checks. Okay, so I steal those guys. All right, let's set me up with that. All right, move me over here. Where are you guys? So just, okay, again, let me go way off the grid here. All right, so let me just go off the grid here. X start. Okay, so, but what do we need? We need another. We're going to need another vector for this. This thing is, these things are not maintained for us. So instead of start position, I will call it previous position. So I can just go ahead and set up an SF vector to F previous position. And just for the sake of the first game frame does not matter when you're setting the thing up. So you can just go ahead and set up the previous position to be the same as the start position. Before time existed, what happened? Well, who knows, right? Okay, so X previous returns that, Y previous returns the Y, previous position dot X equals X, and previous position dot Y equals Y. All right, and this one we don't necessarily have to test out, but we'll fix this up in due time, and we will need this. Say we will fix this up in this video because we'll have to make this thing work. Once we add speed and stuff, like speed is an automatic thing. Okay, so that was simple. Now that we've covered that kind of stuff, so I'm going to take a break here, click here, so I can come back, start fresh. Okay, on to other things here. Let's take a look at the visible attribute, and that means exactly what you would think it would mean. So under the hood, I don't think there's a visible inside of the sprite. Let me see. Let's go ahead and peek at the definition. Sprite, explicit sprite, sprite, get. Let's see what, it's probably easier if I just say sprite dot arrow. Nope, I have to do it over here somewhere. Where do I have access to sprite? Just so I can see, do I have set visibility? Nope. I have color and origin and position and all sorts of stuff, but I do not have access to visibility, so that is something we will have to maintain. And I'll just put that here. It's a bool. I'll make it a bool. Bool visible. And so I need a get and a set. Bool visible. And void get, I'm sorry, set visible. All right, so, okay, let's set these guys up quick actions and refactoring, create definition. Where did they go? Where did they go? Oh no. There we go, visible. So I will just return visible. And in this case, I will just say visible equals visible. And you can add a toggle if you want. Why is that an error in the moment here? I don't know, but we do need to set the constructor up as well because we have to say bool, I'm sorry, not bool, visible, and I'll say true by default because it should be visible by default. Still, let me see what's going on with my error message. Oh boy, oh boy, oh boy. Oh, because, oh, stupid me, right? I have a variable called visible and I have a function called visible, so it doesn't know what to do. The compiler's not smart enough to go, when I see the word visible, does that apply to the function or does that apply to the variable? So I can just, I'll just call the variable is visible. I'd rather change the variable than change and I'd rather make it easier on the end user than on myself. So I just have to go up here and fix everything up. Okay. So then coming back to hero, I could just go ahead and just say, since I've done this already, is key pressed, give me the space bar again, and say, okay, set the visible, not visible, whatever I am now, set me to the other. Let's see, does this compile? Looks good. So I can move around my left and my right, I hit space bar, nothing, right? So I did all the work. But in the object class, the draw still draws no matter what. So it says, as long as there's a sprite, it draws. So if, and so now I'm in the object class, so this is, so I can say if visible. Or I like to say if visible equals true. So now, oh, is visible, sorry. If is visible equals true, now it should be able to draw the sprite, and then now I should be able to make it work. Spacebar, spacebar, spacebar. And again, it's only on the press. We did this in one of the first lectures of getting the keyboard working. There's a difference between down and pressed, right? And there's a difference between up and released. So I press, I toggle his visibility, that little guy there. Okay, so visible is essentially done. So what do I want to do now? I want to do a depth setting. That's something I have to do on my own. I can use a float for that. And so depth ordering is like, when I run this game, let me bring this back here. When I run this game, the depth setting for this guy, see, already takes more than a couple seconds to load, right? That's a real world thing. Okay, so then I am drawn behind the blocks, right? On the walls. I'm in front of these guys, but I'm behind these guys. So but I would probably want to be drawn on top of a lot of these things. But it's not game, it's game specific, right? But I want to have that option. And so what I can do is I can have my float, my depth settings, and then I can set the depth to 0 by default. And I can have some set functions. And later on, we'll do this when we get one of the little last polish ups of this, is we'll get it so that we can sort the vector list inside of the room by the object's depth. So I'll have to make a note to remember to do that. And if I forget, send me a message somewhere along the line and I'll have a video to do that. It's not hard. You just have to, we just have to remember to do it. Okay, so depth is 0 by default. So I just float depth return and void set depth and float depth, lowercase. Okay, and then come on guys, let me go. Here we go, quick actions. Let's create these guys over here. Where are you? Down here. Return. Oh, I did it again. We'll see that again. I did it again. Every so often, a student will send me this, and it's usually it takes. They've been looking at it for an hour. Usually, it takes me only a couple minutes because I've been burned by it so many times over the years. Of a variable and a variable and the function being called the same thing, depth value. I just call it depth value instead over here. Again, it's more prudent to make it a little more inconvenient for you on the engine side than it is for the end user. Okay, so there is depth, and let's move on to something else. Actually, I've decided to just implement the sorting algorithm. So a few things I need to do. I need to set up right here. Every part of this goes into the room class now because it's the room's objective to sort out the objects by depth settings and print ones versus another here. So what I did is I'm using a sort algorithm, and I'm using the actual algorithm part of the standard template library. I'm passing in basically just here's the entire vector of objects, and I'm using the less than operator as the determining tool of this if one object is less than the other, because every object in here is a SFML pointer, so I need to create a function that can handle that operation. And you notice all I'm checking here is pointer versus pointer, left hand side versus right hand side. I'm just asking when it's sorting and it's asking who's greater or who's lesser than the other. It's just asking, hey, whose depth is smaller? And that's all that's, a lesser value. And that's how it ends up sorting the list out. So because of this, then, values, this is the opposite of what GameMaker does, which is the way I would want to do things anyway, is that the larger positive values that you have for your depth value are the values that get drawn closer to your eye. GameMaker has the opposite, where it's more negative, closer to your eye. It's just weird to me. So a 1 will get drawn on top of everything 0, and then -1 and -2 and so forth and so on. So it's positive always wins when it comes to this. So that's all I had to do here. And I will admit to you right now, this is not the best way to go about doing things, to use a sort algorithm every single game frame. So like in a real world example, if I did do this and change the depth somewhere, I would probably set a flag in my room and say, okay, only sort if somebody changed their depth orders while we were, or added an object to the room or something like that while we were doing this. So you don't have to sort every single game frame. But we're never going to see that performance hit because our game is not that complicated. Okay, so all I did then come back to hero, and I just added this code here just to prove that we can move the depth ordering of the player. So you can see there, and so yeah, so you can see the code. You can pause it if you need to, but here you go. I can go right and left, and you see he goes behind, but as soon as I press spacebar, his depth order will change, and now he's being drawn on top of everything because he's been sorted, and now he's at the back of the list. Instead of wherever he was, he's now sorted at the back of the list. So one thing to note, if things are tied, there's no guarantee who's going to go first. Most times it'll just matter on who gets added to the vector first. But if there's a lot of sorting going on, there's called a stable sort versus an unstable sort. Sometimes when there's a tie, sometimes things might move around more than you think. So ties, that's why you set this up, so that you make sure that objects get placed in front of other objects and set the depth orders accordingly. Okay, so I just wanted to add that since I discussed it, and I said, well, why not just show you how it's done? So that's how we go about doing that. Okay, so the next idea I want to introduce here is the idea of alarms. And so alarms are exactly what you expect. A number of game frames will count down, and when the game frames, when that total hits, it will scream out, hey, do something, what do you want to do about this? Just like an alarm would wake you up at 6 in the morning or noon or whenever you wake up. So GameMaker allows 12 alarms per object, and we don't need that many, but I'm going to use a vector anyway, a vector of float. I'll call them alarms. I'm not going to change any of the other stuff here. And so because the float, you could change it, or why don't we just use int? Vector of int for number of floats, or for that kind of stuff. And so depth value here, so I can go, I'm just going to say, okay, alarms, I'm going to use the constructor that says I want 5, and I want to set them all to -1. Oh, no, don't do that to me. I like my formatting. I'll have to find that somewhere and just disable their formatting. Okay, so this sets 5 alarms from 0 to 4. So, and GameMaker starts their alarms from 0, so we're in good company here. And so this is pretty cool. We set everything up. So now -1 means disarmed, 0 means fire away, something went wrong, and then we're going to set the alarm to a positive number, and it's going to count down. So now what's interesting here, our step event, there we go, finally. We finally get to start doing some stuff. So I can say for every single alarm, and so I'm actually going to use, instead of using the range-based for loop, I'm just going to use I'm just going to use a for loop here. For int I equals 0, I is less than alarms.size, because I need this index value. If alarms at the I value is greater than 0, I am going to minus alarms of I. I'm going to subtract one off. That's what one game frame has passed. And now, after we've done this, if, and these are ints, so we don't have to worry about this, if alarms I equals 0, then I have to call an alarm. And how do we, like, what does that mean? And like, we have never discussed that kind of thing. It's a trigger event, right? It's like, all these are, you know, events and all of these things are happening, but there's nothing saying we can't do something like this. And so we'll need functions for setting an alarm, getting an alarm, and in this case, what happens when the alarm goes off. So I will need to set up, let's just set that up right now. So I'll have to set up a void function for getting an alarm value. And in this case, I'll say I need to know which alarm you want, and I'll return the value to you. I'll also need, oh, sorry, that's an int return. So this is a little different, right? You have to, instead of just, you have to tell me which alarm, and then I still will return to you the value of that alarm. And so now with this, I'll just say set alarm, and say, okay, which alarm, because there could be any number of them, and then which value. And then now here's a new one. I'm going to set up a function, called a void function called onAlarm, and it's virtual, because everyone's going to handle this differently, and say which alarm is going off, right? Because, you know, so I'll give it a, you know, give it a basic function that does nothing, but, you know, so this is in the object, but then it's up to you to override this and do something with it if you so choose. So here, let's go ahead and set this up and pop this in over here, and then come back. Where are these functions? Probably at the bottom. Okay, so cool. So right now, onAlarm, do nothing. This one is a do nothing because it's up to you to override. It's virtual. The base behavior is to not give a crap. All right, so set alarm. All I have to do here is just say alarms at alarm equals value. And then here, I'm just going to return alarms at the alarm value. So we've taken care of the tricky work. And so now, yep, so I want this alarm, get me, return it back. It returns an int because it's an int array or an int vector. Give me an alarm, set this alarm to this value, and then in this case, do something when all hell breaks loose and the alarm goes off. Okay, well, I say greater than or equal. Okay, I just want to make sure I do this right. So if it's greater than 0, subtract 1, and if it is 0, do some stuff, right? So just for the sake of this, why don't I just make this greater than or equal to? Because in my thought process, if it's 1, it'll subtract off, call the alarm, and the next time it'll set it to -1, because I do want a -1 to indicate that the thing is basically not set to do anything at all. So what I want to do is call onAlarm, and I'll call onAlarm I. Or the other way around, just if you want to feel better about it, just to say alarms I is equal to -1. Once I call the alarm and I do whatever needs to be done for the alarm, I'm good to go. So yeah, the step event now handles, this is, you know, it's some alarming code there, huh? And but it should handle the alarm events. So now for their hero, where's our, let me pull back and get our hero.h file out of this thing. Drag them over here and say now I can take over. I took over step. What if I take over on alarm int alarm and say, okay, cool, fair enough. And so now what I can do here, if I press the space bar, we've been playing with everything else, I say, okay, set alarm 0 to 60. Okay, fair enough there. And then, why is, okay, let me add you here. And now what I want to do is set x start and set y to y start. So when the alarm goes off, and you could put if statements if you have multiple alarms. You could be like if alarm 0, if alarm 1. But in this case, I only have one alarm that I'm setting here. And so if everything works out, it doesn't matter because there's only the one. If it hits the alarm, then I can put myself back to where I needed to go. Let's see if this works. Cross your fingers. We're into cross your fingers time when it comes to code. Okay, left, right, press. Okay, so I press spacebar, and then 1 second later, it should go back. 1. Oh, it did not work. So what happened? So let's see. Well, first thing, did I actually set the alarm? Okay, spacebar, yes. Okay. Alarm equals. Okay. So now I have a 5-size alarm. Alarm 0 is 60 and everything else is -1. So, okay, the joke's on me so far here. So where is the code? Okay, so let's find that. And so now let's check out what's happening and see what's wrong with my code. You probably already know. If I don't know, let's find out. So alarm 0, go in. Oh, yeah. So yes, exactly. See, one little character, right? If alarm's I is greater than 0, but wait a minute. But well, let's run this one more time. Let me run this one. Oh, I gotta hit the space bar. Space bar, set the alarm, and then hold on, let me make sure. It's like debugging is a big deal, right? So let me make sure I go here. Okay, run. Alarm size 5. Oh, which object? Oh boy. Okay, so let's go hero, step, set alarm. Oh, do you know what's happening? So now this is interesting. I know what's happening now. And so you will see this. I'm thankful to see this. I was going to describe this, and then I forgot, and I'm glad I forgot. Because you're like, what in the world is happening? There's nothing wrong with this, right? But there totally is. And the problem is, because these are virtual functions, I'm overriding the step event, and so the the hero step event does this code, and so all of the code for this cool stuff in here is in the object class above me, but I'm overriding this because I'm doing the code for the hero. And so yes, this is great and all. I'm setting the alarm, but nothing's ever being modified because I need to call, whenever I do this, when I override, I will probably have to call the parent step event. This is like call inherited event, if you're thinking GameMaker, because this will call up and do all the work for the alarms. And sometimes you can put it at the front, sometimes you can put it at the back, sometimes you put it in the middle, sometimes you don't do it at all. That's the fun of customizing these things. Like sometimes you care, sometimes you don't. But I absolutely want the automaticness of my alarm system to handle this on a frame-by-frame basis. So I better call up, and you're going to need this also if you're animating and things like that. We're going to put animations in here in the next video or the video right after that. So let's see. Did I fix this by that tiny little mistake? So I can move, I press space, 0, 1, there we go. 0, 1, because my game is running at 60 frames per second, so it's like a metronome. I got 0, 1, my alarm is working now. And I forget this every so often because in GameMaker it kind of just comes for free because I work with GameMaker a lot. But in this case, like I said, this code gets overridden by the hero code because I didn't explicitly go, hey, call my parent and do the work that all that hard work up front. And all of this code still comes for free because I can hit spacebar. I can still hit the spacebar and it comes along, but now I can do both functions, and I just have to do things that way. Okay, so you have 5 alarms. You can set them like to whatever timetable you want. Like say if I want it to be 1/3 of a second, like it's all in game frames. So I move around in space, 1/3 of a second, 20 game frames have passed, and now he's moved over. And so we'll need this for movement and animations and things like that when we get to the real game, which we're getting closer to. All right, so the last thing that I want to cover when it comes to this stuff, of the stuff I want to cover, and now it comes down to moving the object around automatically, letting the engine just basically give an object some speed in a given direction, and just say go to town. So there are 4 variables a GameMaker uses here. There's h-speed, v-speed, speed, and direction. So they all tie together. And so I say, like, if I change one, I might be changing others. So we have to watch out for this. So this gets a little complicated. Just not algebra, trigonomically. So we just have to watch out for this stuff. So to keep track of the speed variable, or the direction we're going, I do need to have a new vector. I'm sorry, a vector 2f. And, whoops, what did I do? I can't spell. And so vector 2f, and I will call this thing, oh, it's SF. That's what the problem is. Okay, and then I need to know what my speed is. And I'm going to just keep the speed. In reality, it's actually a velocity, right? That's what it is. But just to keep with what GameMaker does, I will go ahead and do that. And the speed of an object when I start out is 0. All right, and just basic stuff there. Alarm, so my speed, 0, 0. Make sure these are floats. Remember, these are floats. So, okay, depth value. Depth's a float too, right? Or no, depth was an int. Let's see, depth is a float. Okay, so I should use 0.0. Okay. Should always use a float whenever. You should always put a float value in just whenever. Okay, so now my speed is 0, 0. And so now, let's say, the easy part is h speed and v speed, set and get, because h speed and v speed are just the components of the speed vector. Because, like they said, there's a horizontal component and a vertical component to movement, and then in essence, you're moving in that direction. So what I can do here is, just to get things going, just to kind of get, I'm going to use floats here for, and I'm just going to call them, I'm going to call everything the same thing, h speed and set h speed. I'll just capitalize this, set h speed. And then v speed. Okay. All right. So I got my h speed, set my h speed, got my v speed, set my v speed. Okay, so then all I'm doing here to get this thing going is find it at the bottom probably, right? Here we go. So in this case, all I'm going to do is return my speed dot x. I'm going to set it. I feel like we've done this a million times, right? Equals h speed, because we have done this already a few times. Speed.y, even though v versus y, I'm just going to keep consistent with what GameMaker does. And then speed.y equals v speed. All right, and that pretty much covers it, because the vector, as in like speed, we can generate speed from this vector, because all it is the hypotenuse Pythagorean theorem to figure out if I have a horizontal speed and a vertical speed, what's my real speed. And then the same thing goes for direction. If I do an arctangent, I can figure out what direction from the two values, what direction the thing is actually facing. So I believe I don't have to touch these two things anymore, because of the way we just kind of set everything up under the hood. And now things get a little more complicated when it comes to setting everything. At least the set functions. Gets aren't so bad. The sets are where things kind of get modified quite a bit here. And if we need to come back and fix up h speed and v speed, we will do so. Okay, so let's just say, how do I get the speed? And then how do I get the direction? So those are the two functions, get, right? So let's go ahead and set that up. Whoops. Okay, so here we go. So to get the speed, I don't know why it gives me an error there every so often, but anyway, so to get the speed of this thing, I can call hypot. Can I? Yep, I can call hypot. So I don't have to write the function myself to square root of, and all it is, give me, actually, now that I think about it, does the vector itself, oh shoot, speed, I'll call it speed vector. I'll have to change everything here. Let me just, well, I can do a rename, and I can change it to speed vector, because again, like I did a few times before, there's a speed function that matches a speed variable and it doesn't know what to do. So coming back, yep, everything's been modified correctly. So I can say, is there a function for length? Nope. All right, so there isn't. So I will have to do the hard work and say, okay, hypot of speed vector dot x and speed vector dot y. And that's all the get function is. It's just getting and returning back, taking the two components and figuring out what the master component is of that. And direction then is an atan2. I said it's an arctangent. And so now you just bear with me, and if we'll try it out later. And it's, you have to negative, the y has to go first in the arctan2 function, and because mathematically speaking, the y-axis goes up mathematically, but in our game, the y-axis goes down. So we have to negate whatever the y component is to get the correct direction. And so I negate speed vector dot y, and then I take speed vector dot x. And one thing I also will want to do in the slight future here is I want to convert that to degrees. GameMaker does everything in degrees, even though some of the functions work in radians. So right now, everything, the speed itself, the h speed and the v speed, those are pixels. But right now, the direction is coming back to you in radians, and I want to turn it into degrees. So how would I go about doing that? So here's the function for that. So because radians can be from 0 to 2 pi, and degrees go from 0 to 360, so it's just a, it's a transformation. If I had 0 radians, then I should get a 0 result. 360 times 0 divided by 2 pi, yes, is 0. But if I have 2 pi radians, I should be able to get 2 pi divided by 2 pi is 1, and I should have 360 degrees. That's the theory behind this. And so I can simplify this. 360 divided by 2 is 180. So I can just say, okay, my number of radians is this whole thing. This is the radians coming back. So I can say take 180 float, multiply it by that, and divide it by, and I don't think there is a pi. So I have to just say 3.14159.26535 float. And that'll give me more than enough precision in float land, because float's only good to 6 or 7 spots, and I know it to 7 or 8 or 9. So that will work out for us. We'll have to test this, but that's how I would get the direction in degrees. So there we go. So then the last thing to do is, like, if this is working for me, is to figure out how to set the speed and set the direction, which is not as easy. Okay, so now I have gone ahead and I've set up the set speed function and the set direction function. And so now we'll do a little trig, we'll do a little jiggery pokery to make this thing work. So as I said, we already have the hypot function to figure out what the speed is currently for what the speed vector is. So it'll always return a positive number because hypot is squaring things, right? So it'll always return the positive value. So speed is always a positive quantity. Velocity is not always. That's why you can actually have a negative h speed, because you could be going left, and you could have a negative y speed because you could, or v speed or whatever you want to call it, because you could be going up. So it's like, so you could have negatives for these things, but when you square them together and then you take the square root, the speed will always be positive. So here is a function. It's not as easy as you might think it is, because I had to think things out here. So if I want to set the speed to a new speed value, basically, I'm basically taking a vector and I'm stretching it one way or another. If I want to, make it go faster, I stretch it out, so I make it like double the speed. I stretch it to go double the speed. If I want to go half the speed, I stretch it to come in half. So it's a matter of proportions. So I get the old speed. Like, what was my speed before I did all this? And I said, if it's 0, that's what it's like. If this falls through, say, if my old speed is 0, well then, right now, because if just the way the math works out, if the speed is 0, then the angle has to be 0 as well, because 0, 0, when it comes to the trigonometry of it, is facing the 0 direction. So I'm just going to say whatever the new speed is, put it in there, put it into the x value. So if the speed comes in as a 0, the new speed is a 0, it'll set it to 0. If it's a new speed is 22, as long as the old speed is 0, it'll just set it so the speed is set up correctly, and then so that the x value is correctly set up. If I neglect to do this, then if I just do a multiplication of this, then it's going to end up being 0. So I'm like, set the speed to 22, and it's like, how about speed of 0? And I go, no, that's absolutely wrong. So just to say, that's where this little else check to make sure that if the old speed was 0, that I do everything correctly. But otherwise, then if the new speed ends up, if the old speed is 5 or something, and you say I want to set the new speed to 0, well, then the factor will be 0. So it handles both cases. So it'll handle just fine if I want to set from 5 to 0 or 0 to 5 or this or that or anything else. So now if the old speed is not a 0 value, then I just say, okay, what is the proportion? So I say I was 2, now I'm 4. Well, that means I want to double my vector. I want my vector to stretch out to be double its previous length. So, and then you don't have to worry about going in and doing the x and the y components separately. There is an operator for this that multiply equals that can handle this factor, so that so to just multiply a vector by a number, and it knows to multiply the x and the y by the same value. So that covers the speed function. So and that will handle every case. I kind of tested it. We'll test it a little more after I'm done talking here. I feel like we're about an hour into this video. I don't know. This is my 7th part that I'm going to cobble together. This is a long video today, or this one. So, but I think this covers speed, and if not, of course, just email me. If you find a fringe case, we can work it out. But I'm pretty confident in the way this works out. Okay, direction uses trig. Everything else has kind of gotten away with, like we've used trig, but we kind of hand waved it. But this one we can't get away with. So to set the direction, oops, I got to put a semicolon here. So to set the direction, what I do is I'm applying trig, because I'm like, I want to get my speed, which tells me the length, the magnitude of this vector. And then what I do is I figure out from there, if I took that length and I change the angle around, like what would be the x component and the y component that gives me in that specific direction, that gives me the length that I'm expecting to see. And that's what I'm doing here. So the first thing coming in is, again, we are going to expect degrees from the end user, the people using our engine, who are playing, who are developing the games. So it comes in, direction comes in degrees. We then convert it. This is a conversion factor here, where I take this multiplied by pi divided by 180, and that'll get me the number of radians. And because I need radians to make the math work, and then I get the old speed, or the speed. The speed is not going to change, just the direction, right? So it's like if I was going 5 pixels per frame this way, and then I say do a 180 without any halting, and just switch up, the speed does not change, but my direction does. So that's the idea here. It's a complete overhaul, a complete J-turn in one frame. And so the speed will not change. If you do the trig right and you do all this, the speed will not change. So then to say I have my direction and I have my speed, I have everything I need to do the trig to convert and figure out what my x component is and my y component. So I can set up a new vector. Speed vector equals new vector, if you want to think of it, not nude, but just a new vector. And it says take the speed, multiply it by the cosine of the number of radians. So that gives me the horizontal component. And then again, I'm negative speed because the y-axis is reversed in gaming versus true mathematics. So what negative speed times the sine of the number of radians. And this should do this. I haven't tested all of this out. I tested the speed function out. And so now here is a chance for us to test out everything we've done when it comes to these 4 functions, just to make sure. And I'm saying we already tested h speed and v speed, or at least we tested h speed. Let's try it all together now, and one final test before we kick off for this video. So all of our hard work we finally get to see come to fruition, and we get to see it all work out. So I wrote some tester code here, as you can see or cannot see. My bulb's burn. Oh, good, thank goodness. You don't get to see that. And so there's the code. And so I'm setting up my hero object like before. I'm giving him a speed of 1 to start. And so he's actually going to start going to the right because the direction is 0. So he's going to go to the right starting out, moving at 1 pixel per frame. And then it's going to update. If I press down, he's going to rotate to the left a little bit. So he's going to start moving, I guess, upward, if you want, rotate around. The image won't, but the movement will. And if I go, if I press the right arrow key, I go to the I go down, I'm sorry, just if I press the right arrow key, I'm going downwards because I'm subtracting, and if I'm going left, I'm going upwards, so I'm turning to the left. So if you want to think of kind of like strafing and turning. And if I press spacebar, I have a one frame alarm that puts me back to my original location to start over again. And if I hit enter, I can test out this and try to subtract 45 degrees from the direction I'm currently going. And so all of this code goes in here, I run this. Here's my happiness, and you're like, nothing is happening. What about all these keys? Up, down, left, right, space, enter, and oh my goodness, what did I do? And so the final thing left to do, there's nothing necessarily wrong with the code in here. It's just, we talked about, I know I talked about it, who knows how long ago now, longer for me than it is for you, that this step event takes care of all the stuff, all the automatic stuff that we want, you know, like the alarm events and all of that stuff. Without this, the alarms will never go off. And so the other thing is, without this step event in here, and we haven't written the code, right? I commented it out just to show you, we haven't written it together yet, is that I need to move the character sprite by the speed every game frame, because that's what speed is. Move every game frame, move every game frame, move every game frame. So all I did inside of the step function for the object is to put this line of code where I'm changing the position of the sprite object, or the sprite under the hood, and I'm just saying get my current position and add my speed vector to it. Move it over however far you need to move this thing over, and do this on a frame-by-frame basis. So again, as long as I remember this function to call the parent, to call SFMLObject from inside of Hero, now when I run this, there's my guy, oops, there's my guy, he's going to the right, I press, what did I press? If I hit enter, return is enter on this for whatever reason, I'm space, return, there's my -45, or my 315, my 270. You can see everything's working out. I hit spacebar, he stops, or he goes back to the start, sorry about that. So, okay, so let's see, go down, spacebar, and then I can press left to go him around, see how he's going around, I go right to bring him back. So everything is working out, the direction and the speed is working out appropriately for everything I'm trying to do. So, for what we need for this game, if we need anything else, we'll add it on the fly, but we took care of all of the big stuff in this long video. And so there's one more long video when it comes to setting up the animations for this thing. And hopefully it won't be as bad as this. But as I said, coming back again, I think now it's just a matter of tinkering with this. And I have a key down, key press event, and again, you could try out anything you want. Set, like instead of this, set the speed to 0, or if I want to say set speed, how about we half this or double the speed? Every time I hit the enter key, he speeds up twice as much. Oops, I need a semicolon. That never stops. There he goes. Every time I press spacebar. And the more I hit enter, okay, so you get the point there that it's working, speed is working, or if I just say, okay, set speed to 0, bring him down a notch. If I press spacebar, there he goes. Up, I'm sorry, enter. Now he's set to 0. So I haven't tested this thing out very much yet. This is what you see is pretty much what I've done. I've tested just a tad bit more than the little bit you've seen me do. So I don't have any test cases working out yet. Something that, like all my TDD stuff to make sure that while I'm working on all these things that all the math works out right. So I don't have that working for me. But anyway, so that is, there's a lot. How many functions did we write today? 2, 4, 6, 8, 9, 11, 13, 15, 17, 19, 21, 25 functions we created in this video today. And I think we're pretty confident. I'll give you 99% odds it works. We'll have to find those fringe cases, those little bugs if they're in here. Because there is one, if you stop the speed altogether, whatever direction you were going in, you resolve down to going 0, because now your velocity is 0, your speed is 0. So when I go to generate that, it tells me I'm going to the right, even if I was going up, down, left, or right. So don't ever stop, and you'll be fine. It'll keep the direction as long as the number decreases to like a small number, something like 0.001. The math will work out, but as soon as I go to 0, it won't. So just be careful on that. Okay, so as always, swardb@cod.edu is my email address. Send me an email. If I screwed up anything, which has been an hour of this, it's been complex stuff, I might have screwed something up along the way, or if I just went too fast or something and you can't see the code, or you just have questions about the theory behind anything at all, send me an email or send me a link or send me a comment here down below on YouTube. So next up, animations, fun stuff, so that we can make the character look like he's moving around just like GameMaker can. And again, we're getting closer. We're 5 or 6 videos away from being done. That's a great thing. Take care, everyone. We'll see you next time.